So good afternoon, everyone, and welcome to today's EARTO webinar in our series on the role of RTOs and collaborative research for EU technological advancement. Thank you so much for joining us. My name is Eleni Dritsakou, and on behalf of the Secretariat, I welcome you to this important webinar with our EARTO member CIDETEC. And today we will spotlight a concrete success story from CIDETEC, which is the creation of the spin-off LANZO batteries, showcasing innovative modular battery solutions for a new space era. Just a short housekeeping before we start. So the session is scheduled to take place until 3 o'clock, and we will have 3 speakers which will present the success story, and we'll have a short Q&A afterwards. Please feel free to post your questions in the chat at any time, and then we can pick up the themes raised right after the end of the the presentations. So we are delighted to be joined by 3 distinguished speakers. First, Jesus Marcos, who is the CEO of LANZO Batteries. Then we have Oscar Miguel, Deputy Director of CIDETEC Energy Storage. And last but not least, we have Manex Laranaga, sorry. Almost. Who is, yes, so I'm so sorry for this, who is the researcher of CIDETEC Energy Storage. So thank you so much for joining us and for presenting this successful story. And please, I give you now the floor, and maybe Oscar, you go ahead.
Okay, yeah, thank you very much, Eleni, for a quick and nice introduction. Good afternoon, everyone. My name is Oscar Miguel. I'm Deputy Director for CIDETEC Energy Storage, and it will be my pleasure to start the webinar of today with a quick and short overview on what we do at CIDETEC and what's the strategy where initiatives like LANZO batteries are fitting, right? So please, if you can go to the next slide. Yeah, okay, so as a first starting point, just to put things into context, overall introduction, we CIDETEC, we are a private not-for-profit research institute located in San Sebastian, a city at the north of Spain, very close to the French border. We are organized into 2 different institutes, as we call them. One of them is CIDETEC Surface Engineering, with this orange color brand logo. And we are CIDETEC Energy Storage. We used to be located around this area in the main picture that you see on the screen. And we moved very recently, well, 1 year ago already, to a brand new building that indeed is the picture that is behind me in the screen as well. And yeah, it's a very good highlight for us because not only we expanded in terms of surface of space available, but also for improving our equipment and capabilities. You go next, please. Yeah, as a very overall picture and figures on our activity in CIDETEC Energy Storage, we cover the whole value chain of the batteries, and our activities are organized into different main topics that are depicted in this circular scheme on the right. From one side, we start with cell development, battery cell technology development, starting from the materials. It means that we are developing lithium-ion, sodium-ion, solid state, and lithium sulfur mainly technologies, battery technologies. And this is also is the first part of our value chain, where we also have the engineering team that develop battery systems. I mean, starting from the cell, they develop modules, battery packs, and so on. So it's where the initiative of LANZO batteries was born, actually. And all of this is done taking into account, for sure, battery circularity, which is becoming a very hot topic nowadays, because it's not only the point that batteries are needed for the green revolution, electrification of the economy, but the batteries themselves need to be sustainable and circular, ideally. And well, as the main two outer layers that cover everything, we have battery testing. Very important for us. We operate one of the largest battery testing centers in Europe in the hands of our research institute like us. And for sure, digitalization is another big topic that is covering all of our activities from the cell design to module pack and battery systems, diagnosis and prognosis of future behaviors, of remaining useful time, etc. So we cover essentially the whole value chain of the batteries from technology development to the final application. And to do this, we have a large team, quite large team, I think, of 150 research people in our CIDETEC Energy Storage Institute, covering, from electrochemists and material scientists to mechanical engineers like my colleague Manesh, that will speak later on, mathematicians, electronics, and this kind of highly qualified engineering and chemistry materials profiles. What we do is done essentially in the benefit of the industry. And as a result, this is reflected in the origin of our income. As you can see, most of our funding comes from direct industry contracts, up to 60% average in the last few years. And all the rest is coming from public sources, half. So far from the European funding that nowadays is also very, very challenging because we are seeing, unfortunately, how the success rates are getting more and more challenging these days, and all the rest from regional and national sources. If you go next, please. Yeah, this is the value chain we cover. We are not dealing with the original raw materials, but we start from the raw materials, from the battery materials themselves. And from this, we build on our value chain. We go to cell manufacturing, battery cell technology development. Then cell manufacturing is very important because we are developing technology at the electrode and cell level, and we need to be able to put this into a format which is similar to the end product, meaning real-like cells. I hear some echo. Maybe someone needs to mute. Okay. Yeah, because I
muted the participants, so please go ahead.
Okay, thank you. And yeah, this is essentially what I mentioned. If you go next, I think it's my last screenshot. Yeah, this one. So all this value chain, for sure, is populated with projects, with cooperation with companies, with customers, and also with partners from the research, from academia, etc., in the framework of regional, European, and any kind of projects. But around that, we have growing what we are calling our innovation ecosystem. And the motivation and the reason behind is that apart from this activity that we have been performing over the years, and I didn't mention that CIDETEC was founded in 1999 with the special, strategic decision to get deep into batteries around 2010, meaning that we have been, 15, 16 years of intense activity in batteries. We have grown a background of technology, of knowledge that is our own ownership, and that together with our managing director, we identified different topics where we could launch different ways to valorize these technologies. Originally, this is the origin of our spin-off companies that are mentioned in the middle. They are following different steps of the value chain we serve. For example, in cell manufacturing, we have CIDECEL, which is a spin-off company of CIDETEC, making use of our pilot line capabilities. I will not get into details for everything because, we need to focus in what we need today, right? But just a quick mention, the next one is OBS, Optimized Battery Systems, dealing with battery management systems development, BMS. Then we have LANZO from the applications point of view. That will be the main part of the webinar today. And last but not least in this line is CUDEBAT, is a company for the end-of-life battery management, meaning recycling and some second life topics. Apart from these spin-off initiatives, we have some other logos in the screen. I just quickly mention Proteo. Proteo is not a spin-off. Maybe in the future we can decide to go this way, but from the time being, Proteo is a web app application compiling all of our, or most of our modeling and simulation capabilities. This is something that we are offering to the market as a paid service in order to apply different modeling approaches at the cell level, at the system level, end of life, etc., etc. We have mobile as well. I mentioned before that battery testing is one of our strengths nowadays. And we reached some time ago an agreement with Mobile, which is the electromobility hub locally. It's a local regional initiative from the government, so that our battery testing laboratory, most of our assets are located inside the building mobility center, so that it's kind of involved in this environment, regardless of the fact that for sure we are open to test any kind of battery for any kind of application. And last but not least, the last law on the screen, top right, is Circular VAT. Circular VAT is another initiative from a different department of the local government, and this is related to the circular economy of batteries. It's an initiative, it's a hub to gather the most relevant stakeholders, especially industrial stakeholders around, and we are promoting the benefits and the opportunities of the circular economy of batteries so that we can generate also business and outcome after this. So this is our so-called innovation ecosystem. It's under evolution. It's something new for us because all this started a couple of years ago, maybe 3. And yeah, and today is the day of LANZO. So to focus a little bit more in this specific topic, I will pass the ball to my colleague Manex Larrañaga, who is from our technical team. So Manex, please take the lead and
thank you very much, Oscar. You can go to the next slide. Thank you. As you all see, CIDETEC Energy Storage has a long-standing reputation as a powerhouse in energy storage. And the world of energy is expanding, and so we are. So hello everyone, I'm Manex Larrañaga, researcher in the Energy Storage System Unit of CIDETEC Energy Storage. And my goal today is to show you how we are taking that decades-long industrial expertise and projecting them toward a new horizon, that is the space sector. However, first let me introduce and give you some context about our work in the unit. We don't just look at the battery cell, as mentioned Oscar. We look at the entire battery system. Our job is to bridge the gap between chemistry and the final application throughout a smart and safe battery system. We deliver everything from specific subsystem to complete battery packs, ensuring every design meets the strictest mechanical, electrical, or thermal standards. And we are application open and chemistry and format and size agnostic. So this approach allows us to work across all the sector, from road to off-road until the aerospace, and always adapting our engineering to the best cell technology for the mission. So to ensure a successful transfer to the industry, we follow a structured engineering path. And if you can jump to the next slide, we can see how is this path. It begins, as usually, with the customer requirements to evaluate the specific needs, and after that, we start working on our development process. What we really offer is a complete journey from the first idea to the finished product. And all this starts by understanding first the customer vision, and after that, selecting the best battery cell technology for the main project. So once we have the right cell, we move into the design of the modules and the battery packs. And this is where we build the physical health of the system. To make sure we are developing the optimum design, we then run iterative advanced numerical simulation, testing the limits of the design digitally. And this allows us to move into manufacturing and prototyping process with total confidence. And finally, we handle the homologation part, so the customer receives a fully certified system. So in short, we take the complexity out of the battery development so our partners can get the market safer. So it is precisely this industrial expertise that we have now brought to a new frontier, that is the space sector frontier. So we can go to the next slide. Yeah, to address this unique demand of the industry, as you know, LANZO Batteries was launched as a dedicated spin-off, and the goal is clear. I mean, to take the highest standards of terrestrial energy storage application and adapt them to the space mission. And for that, we are taking that massive know-how, developing CIDETEC energy storage over the last 15 years or something like that, and we are launching it into the orbit, more or less. But it is not only just the knowledge that we have transferred. The core add value of LANZO is the strategic use of cost components too. So by integrating technology that is already proven and mass produced in the automotive sector into the space system. And this process dramatically accelerates the qualification time and reduces the cost of the production. And this technology transfer approach offers a unique competitive edge into today's space market, because basically it guarantees high-end reliability with unprecedented efficiency. So while, as you can see, while fundamentals and our working structural path remains the same, I mean, as you remember, from the customer needs to the homologated, ready-to-use battery system development, the thing is that in this space application, the requirements changes drastically when moving from this road application to the main orbit. And one of our key milestones in our unit is exactly this, transferring our industrial, electrical, mechanical, and thermal expertise into the space application. So if we move to the field of electronics, so next slide, please. Thank you. Yeah, this one. And our work represents a direct evolution from industrial rigor to space-grade reliability. The foundation lies in our experience in designing VMS control platform in accordance with automotive industrial standards. This framework enables a safety-oriented design that combines custom hardware with advanced algorithms that we have redefined throughout years of battery system characterization. And for a space application, we take this proven architecture and adapt it for the space environment. By applying our technology transfer strategy, this spinning, we leverage high-performance COTS technology to create electronics that are not only smarter and more cost-effective, but also fully prepared for mission-critical demands. And as you can see in the right side, in the V model, our process ensures total reliability. We move from the initial software code and telemetry functions to the rigorous system-wide validation. So the result is a ready-to-use, space-qualified brain that bridges the gap between automotive efficiency and the aerospace excellence. If we move to the mechanical design area, and for example, the challenge lies in balancing a strong structural integrity with the strict weight constraints of aerospace mission. I mean, our main foundation is built on years of developing basically battery packs and modules that withstand the rigorous mechanical stress of the mobility sector. And this experience enables us to create robust structures designed for crash safety and long-term durability. The thing is that within the space framework, this mechanical heritage is adapted to face, for example, the different characteristics as intense vibration profile of a launch. By using this technology transfer of advanced material, optimized manufacturing techniques, optimized designs, we are able to achieve a high energy density without compromising this structural safety that is a compulsory thing in this space application. So apart from that, every design in our unit is backed by intense simulation and a structural analysis, ensuring that the transition from the terrestrial to a space system results in a battery pack that is not only lighter and more cost effective, but also capable of surviving the hostile environments from the space. And I think that this represents a truly remarkable evolution in our mechanical engineering, because after years of developing robust battery packs for cars, buses, and heavy-duty trucks, we are now taking an exciting leap into the world of CubeSat, launchers, and satellites. And in my opinion, I have to say that it is a challenge that we embrace with great enthusiasm. And if we leave the mechanical part and go to the thermal aspects, here, once the structure has survived to the launch of and it reached to the orbit in the space, a new and more or less invisible challenge begins in the thermal management of the battery system, where the transition from Earth to space is perhaps the most demanding one. In our unit, we are used to perform deep thermal analysis at cell level, module, battery pack level, system level, and we are specialized in the design, the optimization, and the hydraulical sizing of the battery thermal management system. We are used to work from the conventional indirect cooling strategies that are usually cold plates that are integrated in the cars, and we work until the new technologies as the immersion cooling one. And basically, the main intention is to keep the cells within their optimal working range. And all this, of course, all the design and all these strategies are integrated, considering high-level safety analysis, such as the prevention and management of thermal runaway critical phenomena. The thing is that when we transfer all this information to the space sector, when we start thinking in the space application, this knowledge must be carefully adapted, as vacuum condition strictly limits how thermal strategies are integrated. So to face these challenges, we transfer and adapt our expertise to develop specialized thermal management strategies for each space application. So by using advanced passive and active strategies and technologies like PCMs, heat pipes, and advanced installation strategies and components, we enable to develop a precise control over the cells and the thermal response of the components, ensuring the reliability and safety aspect in the most extreme environmental conditions. And I think that I jumped the three main areas. So as you can see, the journey from the road to the orbit is more than just a change in the environment. So we will jump to the last slide, because it is a complete technological evolution. I mean, and I think that in this solution we reach the main solution, because by combining 15 years of CIDETEC energy storage heritage with LANZO's disruptive cost strategy, I think that we have built a bridge between this automotive efficiency and this aerospace reliability needs. So our vision is clear, and I mean, the new space era demands larger and faster series with lower cost. And to meet this, our idea is to provide high performance, modular, and scalable design from cost-based solution. And beyond the technology, this is also about the strategic autonomy. I mean, we are ensuring European technological sovereignty by delivering non-dependent, high-performance battery system that reduces size, delivery time, and cost. And I think that's enough from my side. Now, maybe it's better if I leave you with Jesus Marcos, that is the CEO of LANZO Batteries, who will tell us more about this impressive spin-off company, as well as the success stories and the key milestones that have already marked its journey. So, Jesus, the floor is yours.
Yes, thank you, Manes. Thank you, EARTO, for this opportunity. It's very exciting to present always a spin-off, and this one is LANZO. So the previous contest showed that CIDETEC has the expertise, more than 25 years in batteries, has a plan. Let's go to spin-off companies. Has 3 companies around for cells production, for circuit BMS production, and for recycling. So let's go to the sky. Let's go to fly. And this is the idea of LANZO. Let's go to fly. So then what we do was to put the right people in connection. So we started contracting space engineers that know how to go to the space with people who knows about battery. That was CIDETEC. So integrating both knowledge with starting the company. So maybe from this front page, you can pass next. Yeah. Manes has expressed very well where the opportunity was. New space, or let's call it a space with less requirements than before, a space with faster decision, faster actions than before, with more actors than before. So in this context, they're demanding constellations with small satellites, with low cost, with fast production. So something that was very close were automotive production used to be. So in this sense, these skills in how to do it and what to do it was part of the innovation aspect that we have been flying to LANZO. In this context, you can go next, maybe. Yeah, we started where, let's say, the flying what we have. In this sense, we try to go safe, having lithium batteries. We also decide to how to structurate packet this for space conditions. So we manufacturing with skills that Manes expressed very well in thermal, mechanical, electrics. So design for space, in this sense, customize the product and starting a qualification process. In this context, we were very, let's say, lucky to obtain easily the 9100 ISO, so qualified as for space production or space production. And we also use the tools that we have already in-house in CIDETEC, like Proteo for light prediction and twins, digital twins, to know how our batteries will behave. So with this context, you can pass next. We start the production of these batteries with add values in the fourth area. So cost weight, so structurally and materially composed in a design with additive manufacturing that makes these battery packs very, let's say, integrated. With elements inside that assure a long time in space, means that we design a BMS that can strongly support radiation, single events, vacuum, thermal aspects that are related to space conditions. And we try to use, and we are developing inside CIDETEC and CIDECEL, they are high energy cells. So autonomy in Europe, sovereignty in Europe is based on cell productions. So in this sense, is something we are pushing to fly next European cells, and particularly CIDECEL cells with very high energy that goes solid state batteries with lithium metal, lithium sulfur. So there are areas for improving. We are been starting by now with more safe coarse lithium ions, but we'll go next. And with a design that can be modular, reliable, and scalable. Why? If we design by modularity, we can qualify the modules, and then it's easier, faster, cheaper to use the same module to build up as a Lego multiple configuration for different power and energy needs. So this was the approach, and it's been working well with these kind of principles. So our add value, as I said, cost, scalability, safe BMS, high performance, thermal management integrated that can, let's say, affront the space conditions. Next, please. With this context of technology, we have developed a family of 4 batteries, and here are various of them. There are batteries for launchers that we call it Jack, batteries for LEO satellites, we call it LEO. Batteries for geo satellites, we call it OM, and batteries for aeronautics NEST, that we'll call it HAC. So in this sense, the batteries join the skillets of special knowledge, very specialized, the capacity of fast production, but also fast testing. So we are in-house with the whole facilities that has been described by Oscar before, and around mobile and also internally for electrical, vibration, mechanical, thermal. So we can go end-to-end from design the electronic BMS to manufacture the cell, to manufacture the module, to integrate it and testing for the customer. So this is accelerated the process. So you can go next. and was here was I was describing the family of products. As you see how it looks like, they are products that in a modular construction for LEO satellites that goes from, let's say, 50 watts to 1,000 watts. So it's in different modular constructions. We are now trying to qualify some of this in a flight. I will give details later. There is the jack, the launchers, very used in business. So we are now supplying these batteries for the major mini launchers manufacturers in Europe. So within a SCOE, a system that is using for charger analyzer for the battery too. And we are starting the principles of these aeronautics components, aeronautic batteries. We are starting in this sense also with a hybrid solution that we have been tested during the last year. So we are the principles. You have to consider that only are 2 years in action, this LANZO company. So next. Yeah, well, as I said, in space, if you don't fly, you lie. So it means that we have to fly. Colleagues from CIDETEC and LANZO in a clean room that is our first flight. Initially was planned for last year, but you know, SpaceX problems and so on. But we will fly in June this year in OTB. OSI is a capsule that a satellite that deploy multiple satellites in space will be launched with a SpaceX next June from Cape Canaveral in US, and all our battery systems that will supply power for the OCS, the control altitude thruster of this satellite, is being qualified and is already waiting for being on board in a very short time. So will be our first flight experience in say 1 year will this experiment called LANZO. Next, please. As I said, we have been very successful with the family of jacks. The jacks are the launchers, so we get the first contract early last year with Miura, and we are manufacturing a large quantity of Miura's batteries, and we are delivering now already more than 70 units for this particular flight, and we have new contract with new launchers also with these batteries. Next, please. So we have been doing excursions in kind of hybrid aerial hypersonic vehicles, and we have also developed batteries for hypersonic flights. This particular hypersonic company with our system called LEO C500 supplied a couple of batteries for this vehicle too. Next. Yeah, and we did during the last year the first, let's say, trials also for a hybrid battery with supercaps and lithium that has been developed with the modeling and the integration aspect for a VTOL, considering the solution for a hybrid propulsion based on fuel cell, hydrogen, and these batteries that can cover the range between the started and starting the functionation of these fuel cells. So this project is with a group of aeronautics company, and we try to continue to finalize the development and the certification of these batteries for also large, let's say, drones or mini aerial vehicles, as you call it. So next. Yeah, so it's the end, but it's easy to me to say that by now, 2 years from now, LANZO looks a success story, how it has been transferred knowledge in batteries from automotive, let's say, or for heavy vehicles to the space. and we are trying to go in this direction with the help of the colleagues of CIDETEC and with the ambition of LANZO.
Great, that was very impressive. Thank you so much, Jesus, Oscar, and Miguel, for this great overview of your very successful co-creation work, let's say. I have a couple of questions, but before we jump into these ones, colleagues, do you have any question that we can raise? Please feel free to raise your hand, say your name, and then we can ask our key speakers, and then they can answer to you. Any questions from the audience? Don't be shy. No? Okay, maybe it's too early. We need to warm up a bit. So, perfect. We have Marcus. Please go ahead.
Hi.
Say your
Hello,
name,
everyone.
your affiliation, and please go.
So my name is Marcus Jan. I'm with Danube Cell Manufacturing, and until recently I was with AIT. I think Oscar knows me fairly well.
EARTO member.
Yeah, actually, my question was, but maybe it was said and I just didn't get it properly. But where exactly do you actually get the cells from? Because I mean, I understand you basically make the modules, you do the packs, you do the integration and so on. But how do you get to the cells? Because I know that they are a critical issue, especially for defense metal, right?
Yeah, well, I can answer. We have three sources. We are starting with, let's say, commercial sources, the lithium-ion NMC that we can find in the market. That has been selected especially because they have some space heritage, basically. This was to be safe. This is the fair part. Then we are doing internally within CIDETEC qualification for CIDECEL cells. That is also in the area, as I said, solid state lithium metal, and is very, very promising technology also because the energy and the let's say the lifetime, the security of these sort of cells. Yeah, this is a second source in where we are working. In two versions, today pouch and in next will be cylindrical. And the third sources is we get some elements on some cells that are now in the commercial, let's say, supercaps or others that are doing by partners. And we try to integrate it in our batteries packs for a particular hybrid application in this case.
Thank you for that. Thank you.
Thanks, Jesus. Thanks, Marcus, for the question. Anyone else? Please, Nikolai, the floor is yours.
Hi, I'm Nikolai Gaukos from Sintev in Norway. I just have a quick question, like for space application of these batteries, what is the most challenging part? Is it the temperatures or is it radiation of some sort? Or yeah, what are the biggest issues with batteries in space?
Yeah, maybe if you want, Jesus, I will have a small doubt. I mean, I think that there is not only one big issue. We have more than one. I think, as you say, the issue that I will highlight will be the main specific baking characteristics that we have to face from the thermal management aspect. And apart from that, the radiation is something that you have to consider. Apart from the main structural and component selection, you have to consider for the design of the electronic components. It's something that impacts. And from the thermal management aspect, it's not something related to the casuistries that we have in the terrestrial application. So all the conceptual strategies that you have to implement in these applications are quite different. So you have to start already designing and already defining how to develop this thermal management strategy that will control the cell temperature in the optimum working range, because the range that you can have in one orbit are quite harsh.
Thanks. And can I have a follow-up on the chemistry of your battery cells? So are you using liquid electrolytes, or are you also looking into solid-state batteries?
Well, we can do both, really. I said we are looking for solid, as I said before. We are looking for solid in lithium sulfur, lithium metal. We are looking for that, but we are trusting today with NMC's electrolytes. Yeah.
Thank you very much.
Mm.
Thanks, Nikolai. Anyone else who has a question? No. So if I can jump into Jesus, in your concluding remarks, you talked about tech transfer. So I would like the perspective of all of you on what were the key steps that helped run a research idea at CIDETEC into a qualified product and a super successful spin-off like LANZO.
Maybe if I can, maybe Jesus is going to.
No, Oscar, you go ahead.
Yeah, okay. So maybe my impressions from the side of CIDETEC, and just a quick comment. Yeah, I would say that for some years so far we were identifying the aerospace and particularly space market as a promising one, a challenging one, different one of the very highly populated, let's say, automotive and so on. And that was kind of attractive for CIDETEC to do something in this area. But two comments. From one side, I think from a very specific market like this, so different from what we were used to, which is automotive essentially, I think it's very important to have the right person with the right knowledge and the right even contacts and insights. And from this point of view, having Jesus on board, by the time he was not a member of CIDETEC staff, we were working with Jesus as an external advisor in these areas. And somehow we could engage him in this challenge that he was also a strong believer. And I think without someone like Jesus, that wouldn't have been possible, because he knows the market, the main players. He knows how to move around this new for us sector. So this is very, very important side of the thing. And the other side, maybe more technical, I will say that as we were discussing, automotive is what is, pushing the battery technologies today, right? So we are all of us used to the challenges, the requests, the needs, and the key parameters for an automotive. So changing our minds to the new requisites and KPIs and so on from such a different sector, I think is also kind of mind-blowing for our team. But maybe Manex and Jesus can discuss more on this side.
Well, if I may, I think sometimes you have to arrive in the right time with the right people and with enough money. I think these are the three elements that's been found in this opportunity. It was a right moment for a space in considering these costs, because before was difficult to do it. It was more a unique, let's say, satellite with a large and big primes. So no chances for small companies to go inside the programs so easily. Second is like 25 years of knowledge of batteries is good enough to be, let's say, chances of to find this new market, new opportunity. And really, we have been covering with not only with CIDETEC, also with funding partners like IDAE that we have here on board. So we get, let's say, the enough budget to cover this early stage of developing and fly that was important for the company. Mm-hmm.
Okay, if you want, I can one last
Please.
sentence.
Yes.
Totally agree with Oscar and Jesus. And I think that one of the is something that I have to highlight is the good collaboration and the adaptation capacity you'll have in the unit and between LANZO and CIDETEC people, and all the collaboration on all the capacity to discuss about different topics, how to transfer all the knowledge from one side to the other one. And I think that the illusion of the people to jump to the new sector of space and to work with different concepts and with different people. And I think that it was a big challenge, and I think that we faced proudly, so we are quite happy.
And you should be, just maybe a last question, maybe for Jesus. You can all reply if you want to. You just dropped a news, a promising idea that something will happen in June, the LANZO BAT in orbit test. So maybe could you elaborate more on this one, and what are your main goals and the ambitions that will be fulfilled in 3 months from now?
Yeah. Well, as I said, in orbit validation is important because show to all the others and to you that what you are in design and manufacture is valid for space conditions. So means that is not only what you can prove on testing on ground that is needed, that this battery in this particular case stay for a long time in orbit. So this fly, as I said, is inside a mission that has been called OCE. That OCE is a transfer vehicle. We call it that. It's a vehicle that has a multi experiments, a multi satellite, and will be display this in space in this kind of facility that will do that. That's been built by a company in called EARTO that propose, let's say, in-flight demonstration very fast, very for let's say for customers. So inside this satellite, there is as others a controlled altitude. And this control altitude thruster need a battery to fit this thruster during the mission. It's a mission that will be located in Leo for 5 years, and in this sense, our battery has provide this the power need for this thruster. So this for this particular one, we have been let's say develop the smallest battery of the series. It's a battery LANZO BAT call it that goes with let's say 8 cells distributed in to provide about 200 watts for this particular mission, and has been built and designed, and also was very challenged to design a BMS, electronics control that can pass all the challenges of space requirements, particularly, as I said, by using these COTS components. So components that are more commercial, let's say, that not prepare specifically for space, but we do some protections in some cases for being able to use. And yeah, this is the mission that we'll launch with the launcher that provide SpaceX in June.
Very good, very good. That's clear and very promising. Maybe Manex and Oscar, you have some final comments that you want to share with us?
Well, I think we explained what's the origin of LANZO. And in our case, it's not an isolated initiative, as I explained in my introduction. It's a part of a broader scope from our side in order to valorize technologies that we have, what we, let's say, we consider what we master, and how to reach the market more directly. and also in sectors that are less usual for us. So I think, I mean, my conclusion is that maybe we research operators, we are most of the time working in specific projects for specific customers for specific sectors. Sometimes from time to time, maybe we need to think a bit more broader and be bold enough in order to explore this kind of alternative ways of channeling our knowledge into the market. So I think it might be my conclusion.
Yeah, I agree with Oscar, and to finish a little bit with this question, I think that there is a sense of excitement, the unit and with all the people. So I think that we'll be doing some new projects, new products, and new solution that will be innovative and quite attractive for all of you. So that's my future perspective.
Very good, exciting and optimistic perspective. Very good. Thank you so much to all of you, Manex, Oscar, Jesus, and to all the attendees. We will share with you the presentation and the recording. Please engage with us on the next series of this EARTO webinar on showcasing the RTO's collaboration and the creation of spin-offs and new technological advancements. Just a quick reminder before we conclude, please, we kindly invite you to our annual conference on the 10th of June, which is kindly hosted by IMEC and Vito here in Brussels. Block your calendar in case you are available. We will be very pleased to see you in person, and we stay in touch. Thank you so much. Bye, everyone. Bye-bye.
Thank you very much.
Bye-bye.
Bye.
Thank you. Bye-bye.